If you don't have steel or concrete, how do you build a bridge that can stand for 1400 years? Our ancestors somehow managed exactly that. In the beginning, people crossed rivers by placing stone piers in the water and laying big flat slabs on top. Naturally, they called it a bench bridge. It worked fine for narrow streams. But once the river got wider, those stone slabs would start to sag and eventually crack. So you came up with an idea. Just add more piers to shorten the span. But that created new problems. Too many piers blocked boats, and during floods they were easily smashed apart, often taking the whole bridge with them. One day while exploring a cave, you notice something curious. The cave is hollow, yet the ceiling doesn't collapse. The secret seems to lie in its arched shape. Inspired, you decide to imitate that form. Build a stone arch connecting the two banks. But during construction, you discover a major issue. Irregular stones leave gaps, and even if you fill them with gravel, the arch collapses because the force isn't evenly distributed. So you refine your method. You carve each stone into a wedge, wide on top, narrow on the bottom. Now, when the arch is complete, the stones lock tightly together. As they push against one another, the force travels along the curve and into the abutments on both sides. Suddenly the entire structure becomes stable without needing any piers at all, giving floodwaters and boats a clear passage. Early stone arches were perfect half circles. This increased the span but also made the bridge absurdly tall. Crossing it felt like climbing a hill. Not ideal for carts, horses, or anyone on foot. So you innovate again. You change the angle of each wedge-shaped block, pressing the tall semicircle down into a graceful, flatter segmental arch. To prevent the stones from shifting, you link them together using iron clamps, binding the arch into a single solid unit. The bridge deck becomes stable, wide, and easy to walk across. But just when you think you've solved everything, another challenge appears. During violent floods, even a large arch can be battered by overwhelming force. To relieve pressure, you carve two smaller arches on either side of the main one. These auxiliary openings help divert water and lighten the overall structure, making the bridge even safer and more resilient. Still, strength alone isn't enough. You need protection as well. So you carve dragon heads on both sides of the arch crest. They're not just decorations. When heavy rain falls, water gushes from the dragon's mouths, sparing the bridge from erosion. At the same time, the imagery embodies people's hopes for peace and guardianship over the river. Congratulations! You've just designed the legendary Zhaozhou Bridge, the first truly great stone arch bridge in the world. For over 1,400 years, it has endured countless floods, wars, and earthquakes, a true marvel of ancient engineering.